You know the drill by now. I'm making a game in easy FPS Editor called Scarlet Harvest. And after several months of work, I had a storyline and some sketches of weapons and enemies. Normally at this point, I'd start making level 1 and get myself so tied up in knots and bogged down with asset creation that I'd never actually finish the game. For previous examples of this, see, well, every game I've ever made? This time I wanted to try something different. I wanted to make all the weapons up front, so I at least had some way to build in player progression from the outset. I also finally wanted to fix that wretched shotgun. So this devlog is wholly and exclusively about how I created the 8, so far, weapons for Scarlet Harvest. I started by sketching more weapon designs. Taking inspiration from 90s FPS games, I wanted each weapon to play slightly differently. Easy FPS Editor essentially supports 3 types of weapon. Melee weapons like fists, bats, crowbars and knives, which inflict damage in close proximity to the player. Projectile weapons that fire a sprite at an enemy at a given speed. If the projectile hits the enemy, it deals damage. Easy FPS Editor also supports projectiles that explode on contact with an enemy or wall, dealing damage in a set area. Lastly, there's hit scan weapons. Here, at the moment of firing, a ray is drawn from the player to the horizon, and any enemy blocking that ray is dealt damage in an instant. There's no way for an enemy to avoid damage from a hit scan weapon unless you tweak the accuracy to randomly point the ray off in odd directions. This is known as spread. Using just these 3 types, plus Easy FPS Editor's inbuilt parameters for rate of fire, recoil, reload speed and ammo capacity, can give a surprisingly diverse range of weapon play styles. So I designed weapons to exploit this. The assault rifle is a rapid-firing hit-scan gun, but deals low damage over a somewhat wide area. The railgun is also a hit-scan weapon, but deals high damage in an extremely accurate single shot, but has low ammo capacity. The plasma gun fires high-speed, low-damage balls of energy. The rocket launcher fires high-damage explosive projectiles that damage everything in its area of effect. The plan was to model and animate each weapon in Blender, using the resulting images as my sprites. Because I was after a 90s aesthetic, I mostly ignored all the fancy PBR features Blender offers, instead just creating a 1024 by 1024 diffuse texture for each gun. The exception being the plasma gun, which relied on a simple glass shader and some reflective brass detailing. I finally remade the shotgun to be much better proportioned. But to avoid the spindly arms of the original, I knew I couldn't use the FPS creator arms I'd used before. I tried to use Game Guru's default arms instead, but they, didn't look great.
Daddy, would you like some sausage? Daddy, would you like some sausages? Daddy, would you like some sausage?
In the end, I splashed out on a set of rigged arms from CG Trader. It's funny, you think you know Blender pretty well, and then you open someone else's blend file and
What the hell?
after a bit of fiddling, I realised the rig supported inverse kinematics, which made animating much easier and more realistic. Now I had to decide how many frames of animation I needed. By default, EFPSE only requires 7 frames of animation for a fully functioning gun, but you can force it to use more frames if you write a finite state machine for it. This sets out exactly which frame to display when and for how long. It also enables you to add new animations like reloading, which was important for several of the weapons I had in mind. I tried capturing footage in Warzone at 60 FPS and then undersampling it to see how few frames I could get away with while still looking smooth-ish. 15 frames per second seemed the sweet spot, and wouldn't result in too many frames. I then set about animating each gun to have fire and reload animations. Some guns also needed a special holster animation too for when they are selected and put away. In the previous version of Scarlet Harvest, I'd used a posterize effect to crush the number of colours in the sprite to give it a more retro look. I couldn't really explain why I liked this look, I just knew that I did. So I did some research into the history and hardware of computer graphics and discovered 8-bit colour. I'll go into this in more detail in my next video, but essentially, VGA graphics display controllers of the late 80s and early 90s could only handle a limited amount of data, so colours had to be compressed into one of 256 shades. By the time 2.5D shooters were coming on the scene in the mid-90s, 8-bit colour was a standard, so games like Doom, Duke Nukem and Blood all adopted it for their sprites. Since I was also making a 2.5D shooter, it seemed appropriate to also adopt this aesthetic. I found an app called SLK Image to Pixel, which allows you to crush the number of colours in an image to whatever number you'd like. You can achieve some really stylised looks using this app, and it supports dithering too. But I decided 256 colours was best, with some slight saturation tweaks to make my sprites pop more. To create my own palette of 256 colours, I threw together a compilation of several screenshots from the original Scarlet Harvest, some menu art, and some of the weapons I'd already modelled. Image to Pixel compressed this into 256 colours and let me save it as a palette I could apply to all future sprites. I then began converting my weapon sprites to 256 colours, initially one by one, until I found a newer version of the app that could batch process them. There's one problem with 8-bit colour. It only supports a 1-bit alpha channel. Pixels are either fully opaque or fully transparent. That was a problem not just for the nice anti-aliased edges of my sprites, but also the semi-transparent bits like muzzle flashes. To get around this, I'd take my 256 colour sprites, import them back into After Effects, and use the original Blender renders as their alpha channel, re-exporting them as 32-bit PNGs. It gave me the compressed, dithered look I was after, but still allowed for semi-transparency and smooth edges. As with the previous version of Scarlet Harvest, I used Adobe Audition to make the sounds for each weapon, deliberately compressing almost every one to 11,025 Hz mono to sound more retro. To get the weapons displaying properly in EFPS Editor, I learned to write finite state machines for them. Each one looks a bit like this. There's a series of predefined states like idle and reload, and you define how long you want each frame to display on screen for in order. In my case, at a rate of 15 sprites per second, each sprite needed to be on screen for 66.67 milliseconds or 0.0667 seconds. The three numbers here can be used to offset the sprite's location on the screen, if needed. Lastly, you can add one action per frame. For example, you can play a sound, or reload the gun, or simply jump to the next state in the sequence. Before long, I had 8 really rather impressive weapons working in EFPSE. It was now time to repeat the process but for the enemies. Thanks to my work on the previous version of Scarlet Harvest, I already had 2 enemies modelled and animated. So it wasn't going to take long to get those working in-game, surely. Wait, what? It was at this moment I knew I fucked up. And not just with the enemies, but with every single weapon I'd just made. To find out how monumentally I'd messed things up, and what I'd tried to do to fix it, subscribe so you don't miss my next video. Thanks for watching.